Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for DTC P2647, which corresponds to a high voltage issue in the rocker arm oil pressure switch circuit of the Honda CR-V models from 2011 to 2016. This error indicates that the vehicle's powertrain control module, PCM, has detected an unusually high voltage in the rocker arm oil pressure switch circuit. The rocker arm oil pressure switch plays a critical role in monitoring the oil pressure within the rocker arm assembly, essential for the variable timing control (VTC) system's performance. This system manages the timing of the engine's valve operation for optimal fuel efficiency and engine performance. When the system detects high voltage, it may affect engine performance, fuel efficiency, and idle stability, indicating a need for immediate attention. Understanding the components involved and their interactions is vital for resolve this issue effectively. DTC P2647 specifically relates to the rocker arm oil pressure switch, which is designed to measure the oil pressure in the VTEC rocker arm assembly. This switch is located under the valve cover, cleverly designed to ensure accurate readings of the oil pressure throughout its operation. Its wiring connects directly to the powertrain control module, PCM, which processes the signal received from the switch. When the PCM detects a voltage outside the normal range, it triggers the DTC P2647, signifying a fault that could compromise the vehicle's performance. This high voltage could be caused by a short in the wiring, a malfunction within the switch itself, or an issue arising from related components, such as the rocker arm oil control solenoid. Therefore, pinpointing the source of the high voltage is paramount to rectifying the problem and restoring the car's performance. Several factors can contribute to the occurrence of DTC P2647. One initial possibility is a low engine oil level, which could prevent the rocker arm from obtaining sufficient oil pressure, leading to an erroneous high voltage reading. Another likely cause is a faulty rocker arm oil control solenoid, responsible for managing the oil flow to the rocker arm assembly. Damaged wiring connections or poor contact at the terminals can lead to unreliable voltage signals. Furthermore, a malfunction within the rocker arm oil pressure switch itself may also cause high voltage outputs. Lastly, problems with the PCM, including outdated software, can misinterpret signals from these components. A thorough inspection and testing of all these potential causes are essential to resolve this issue efficiently. The symptoms of DTC P2647 can significantly affect the vehicle's operation. A common initial sign is the illumination of the check engine light, alerting the driver to a malfunction in the engine management system. As the rocker arm oil pressure is crucial for engine performance, drivers may notice a decrease in overall engine performance, including sluggish acceleration or decreased responsiveness. Increased fuel consumption might occur due to improper valve timing, leading to inefficient engine operation. Additionally, a rough idle may be observed as the system struggles to adjust the timing correctly. Lastly, continuous monitoring of oil pressure may become unreliable, resulting in potential further issues if not addressed timely. Recognizing these symptoms quickly can prevent more severe consequences. The first step in troubleshooting DTC P2647 is to check the engine oil level. An insufficient amount of oil can lead to inaccurate readings in oil pressure, which may trigger the high voltage code. It is essential to ensure that the oil is at the appropriate level. If the oil level is within the recommended range, proceed to the next step. Conversely, if the oil level is low, adjustments should be made to restore it to the correct specification before continuing the diagnostic process. This step is vital because even seemingly minor issues like low oil can cascade into more complex solutions if not addressed initially. In the second step of troubleshooting DTC P2647, conducting a VTEC test using the Honda Diagnostic System, HDS, is crucial. This test helps verify if the VTEC system is functioning correctly. If the VTEC test indicates that DTC P2647 is present, it's advisable to progress to further troubleshooting. However, if other DTCs are displayed, those must be addressed first. The VTEC system itself plays an important role in modifying valve timing, and any errors here can lead to the issues embodied in DTC P2647. Should the test results return satisfactory, it may signal intermittent failure and direct attention to possible wiring issues or connectivity problems at critical terminals related to the rocker arm oil pressure switch, the rocker arm oil control solenoid, or the PCM. Step 3 involves closely examining the results from the VTEC test to determine the specific failure area. If the test indicates a VTEC switch failure or reveals other issues such as an open circuit, taking further action is imperative. Should the VTEC test return a negative result, it suggests that the signal from the rocker arm oil pressure switch may be compromised. It's necessary to investigate the condition of the wiring or terminals connecting to the rocker arm oil pressure switch for any signs of wear and tear. If those connections appear suitable, the next logical step would be to replace the rocker arm oil control valve, as it might be malfunctioning, causing the system to misinterpret oil pressure readings. In Step 4, checking the internal resistance of the rocker arm oil pressure switch is critical. To conduct this test, first, you must turn the ignition switch to lock, 0, and disconnect the rocker arm oil pressure switch 2P connector. This allows for a clear assessment of continuity between the designated test points. By measuring between test points on the disconnected switch's side, the internal resistance can be evaluated. If continuity is confirmed, the switch may still function adequately. Conversely, if continuity is not detected, the rocker arm oil pressure switch itself is likely faulty, necessitating replacement to ensure the correct system operation and prevent high voltage errors. Step 5 focuses on checking the open wire in the LG2 line, which is responsible for transferring the voltage signal to the rocker arm oil pressure switch. After ensuring the ignition switch is in the on-to position and disconnecting the rocker arm oil pressure switch 2P connector, you will measure the voltage between the defined test points. A proper reading of approximately 5.0 volts indicates that the LG2 wire is functioning correctly. If voltage is confirmed, the wiring is intact, and it would direct attention towards possible issues further along the circuit. If not, this points to a fault in the LG2 wire between the switch and the designated ground point, requiring repair to restore proper function. The final troubleshooting step involves the continuity check of the VTSW line to ensure it is functioning correctly. First, set the ignition switch to lock, 0, and jump the SCS line using the HDS. After this step, disconnect the necessary connectors at both the PCM and rocker arm oil pressure switch. Measuring the continuity between specific terminals allows for verification of the circuit's integrity. If continuity is confirmed, it must then be evaluated whether the PCM requires software updates or possible replacement if the software is outdated. If continuity fails, it confirms an open in the VTSW wire between two connected components, indicating where repair is necessary to resolve the drought in circuit functionality. Once the necessary repairs have been conducted, verifying that those repairs have succeeded is vital for maintaining optimal vehicle performance. This step involves reconnecting all previously disconnected connectors accurately to ensure continuity through the repaired circuit paths. After this connection, the ignition switch should be turned to on 2 to reset the PCM with the Honda Diagnostic System HDS. Following this reset, performing the PCM idle learn procedure will help recalibrate the engine management system to its ideal settings. After letting the engine idle and assessing its state, it is essential to check for any remaining pending or confirmed DTCs using the HDS. This reiteration confirms that no further codes emerge and that the vehicle is operating efficiently post-repair. Implementing preventive maintenance is crucial for avoiding future occurrences of DTC P2647. Regular checks on the engine oil level should become a rite of passage in vehicle upkeep, ensuring that it remains within the manufacturer's specifications. Low oil levels can lead to false readings and potential faults. Additionally, routine inspection of wiring connections related to the rocker arm oil pressure switch and solenoid should be performed. Over time, vibration and environmental factors can impact connections, creating faults. By regularly maintaining these components and conducting periodic diagnostic checks can prevent unexpected breakdowns related to high-voltage issues, ultimately extending the life of the VTEC system and engine longevity. In conclusion, troubleshooting DTC P2647 requires a meticulous approach, focusing on examining prevalent causes ranging from oil levels to communication between crucial components such as the rocker arm oil pressure switch and the PCM. The steps laid out provide a systematic breakdown for identifying and rectifying faults associated with high-voltage issues in the circuit. Monitoring symptoms that surface in conjunction with this error code aids in addressing any underlying issues promptly. Regular preventive maintenance plays a vital role in ensuring the longevity and efficiency of the VTEC system, enhancing the overall driving experience. Together, these actions contribute significantly to better performance and reduced likelihood of future operational issues. Please like and subscribe to the channel. See you next time.